negative 1/2, or sine inverse of negative 1/2. So you go to your unit circle and figure out where sine equals negative 1/2. It equals negative 1/2 right here, and it equals negative 1/2 right here. How do I know which one to use? How do I know which one to use? We have two possible ones, but we can't give both answers, so we have to pick one. Gracie? Sine is in quadrant 1 and 4 with so much enthusiasm. But we can't put 11 pi over 6 because that means that you went all the way around this land that does not exist. Since sine inverse only exists in these two quadrants, you only can go up and you can only go down. So these all have to be negative angles. So this is going to be negative pi over 6. Are we getting a little clearer on that? The more times we kind of correct it. All right, the next one is arctangent of square root of 3. Arctangent of square root of 3. So we locate where tangent equals square root of 3. It equals it there. And it also equals it down here. Which quadrant does tan inverse live in? Which quadrants does tan inverse live in? Whew, this is going to take a long time. Fritz? 1 and 4. So we're going to take the one in quadrant 1, which is pi over 3. All right, the next one is arc cotangent square root of 3. Now, cotangent isn't on my unit circle. Cotangent isn't on my unit circle, so I have to use tangent. When we're using inverse, we're going to use the tan inverse of the reciprocal. Inverse, do the reciprocal inside. Anytime you're doing cotangent, secant, or cosecant, you're always thinking reciprocal. When we're doing the inverse, we do the reciprocal inside. So that's the tangent of 1 over square root of 3. Well, that equals the tan inverse of multiply the top and bottom by square root of 3. We are going to have square root of 3 over 3. We go to our unit circle, locate where tangent equals square root of 3 over 3, which is right here. We are already told it must be in quadrant 1 or 4. That's quadrant 1. So our answer is going to be pi over 6. So the majority of you got that correct, which is awesome. All right, cosecant of pi over 3. Cosecant of pi over 3. We need to, since cosecant isn't on our unit circle, we need to use sine, which means we're looking for 1 over sine of pi over 3. In other words, find your sine value at pi over 3 and take the reciprocal. So we go to our unit circle, and at pi over 3, pi over 3 is right there. Sine is going to be square root of 3 over 2. So if I take the reciprocal of that, that would be 2 over square root of 3. When you get rid of the multiply the top and bottom by square root of 3, you'll get 2 square root of 3 over 3. Secant is not on my unit circle, so I'm going to do the reciprocal of 1 over cosine 5 pi over 4. We find cosine of 5 pi over 4, and then we take the reciprocal of it. So 5 pi over 4. 5 pi over 4 is way down here. Yeah. You sure? Yeah. Okay. Which is going to be negative 2 over square root of 2. Negative 2 over square root of 2, because I just took the reciprocal. Multiply the top and bottom by square root of 2, and you're just going to have negative square root of 2. Finally, cotangent. If we're looking for the cotangent, we're looking for the reciprocal of tangent of pi over 2. That means we just go to unit circle and find pi over 2. Pi over 2 is right here. The tangent's undefined. If the tangent is undefined, it's undefined because it is 1 over 0. That's what makes it undefined. The reciprocal of 1 over 0 is 0 over 1, which is defined and will actually be 0. I'm going the wrong direction. All right, I just wanted to have kind of these right next to each other, where if we do arc cotangent, we take the reciprocal inside, and when we're just taking regular cotangent, we take the reciprocal, kind of what I picture on the outside or at the end. The reciprocal does not happen inside the parentheses. All right, any questions on those? We have a test on Wednesday, and you better believe that there's going to be several of those on there. In fact, I think it's kind of like a page of going through all your different values. Sine, cosine, cosecant, secant, tangent, cotangent, and their inverses. All right, so that's going to be a big page of points. So if you don't understand how to do this, now's the time to meet with me and ask questions. Okay? All right, today we're just going to get into some little easier conceptual-wise stuff. We're just going to talk about the basics of right triangle trigonometry. So in fact, most of this will just be review. We're just talking about, we're getting away from the unit circle for a second, and we're just saying I have a right triangle. Find the sine, find the cosine, find the tangent, find the cotangent, find the cosecant, find the secant. So just remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That comes from SOHCAHTOA. And the other ones are just the reciprocal functions. So once you know sine, you can flip it, and you now know cosecant. So if I'm given something like this, I have a triangle like this. For sine, I need opposite over hypotenuse, so I need a hypotenuse. Does anyone just remember the hypotenuse of a 3, 4, 5 triangle? It's going to be 5. Let's say you did not remember that. Just remember a squared plus b squared equals c squared. So you can go 3 squared plus 4 squared equals your c squared. So that'd be 9 plus 16, which would be 25. Take the square root of both sides. Boom, boom. And either way you have it, you have c equals 5. Well, that means sine. Here's the trick. Make sure you're looking at the right angles. That's going to be the trick for today. Make sure you're looking at the right angle. They said sine of theta. Theta's in this corner. So opposite's going to be the one furthest away from that corner. So that's going to be my opposite. That'll be my 3. So sine is going to be 3 over the hypotenuse, which is 5. Cosecant is going to be the reciprocal, which is 5 over 3. So typically I do it in that order. I do sine, then cosecant. Then I do cosine, then I do secant. Then I do tangent and cotangent. My cosine's adjacent. Adjacent of theta is just going to be the one that's attached to it. So it's going to be 4 over 5, which means secant is 5 over 4. Tangent is TOA. That's opposite over adjacent. Like I said, opposite's always going to be the one furthest away from the angle. So that's going to be 3. Adjacent is the one attached to it. So that's going to be 4. So TOA, opposite over adjacent, is going to be 3 over 4. Cotangent is the reciprocal of that, which is 4 over 3. Sometimes they won't give you the sides. They'll give you what your cosine theta equals. So your cosine of angle theta equals 4 over 7. Well, cosine, so TOA is adjacent over hypotenuse. So they did give you the hypotenuse, and they also gave you your adjacent side. Now you just have to figure out that missing side using that a squared plus b squared equals c squared, right? Oh, sorry. So I stole your thunder? Okay. All right, so if we do a squared plus b squared, so we have 4 squared plus whatever that missing side squared equals 7 squared. Well, that's going to be 49. Make sure I didn't have any additional notes. I did not. So we will have 16 plus b squared equals 49, which will mean that my b squared is going to equal 33. Yep. Take that square root. and you are going to have b equals the square root of 33. Square roots, you're going to try to simplify as much as possible, but there is no perfect square that goes into 33. 4 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it, so we're just going to leave it as square root of 33. All right. So let's go ahead and tackle our sine. Our sine is going to be opposite over hypotenuse, so that's going to be square root of 33 over 7. Cosecant, you're going to flip that, so it'll be 7 over square root of 33. But we need to get rid of that square root in the denominator, so we multiply the top and bottom by square root of 33. And that's going to equal 7 square root of 33 over 33. I promise you, if you're running out of time and you don't want to simplify stuff, this isn't worth a ton of points. All right, if you don't simplify or make your radicals outside the denominator, if you don't do that, it's like minus a half point at most, even on the entire thing. All right, so our secant is going to be the reciprocal of our cosine, so that's 7 over 4. Our tangent is opposite, which is square root of 33. Over adjacent, which is 4. So our cotangent would be 4 over square root of 33. Multiply the top and bottom by square root of 33. You'll get 4 square root of 33 over 33. Cool. Sine, cosine, tangent, so on and so forth. Now we're going to add to it. You have to really pay attention to this. This is nearly the exact same problem. These are in fact, they're exactly the same problem. They're exactly the same problem. However, they're giving it to you in different form. They're saying that there's some point for -2, and they want you to find that angle. Now pay attention here. For -2, let's go ahead and plot it. 1, 2, 3. Oh, I'm way on the wrong one. 1, 2, 3, 4, -1, 2. I'm going to plot that point. This is the point for -2. Now we're going to treat these like reference angles. You're going to create, so first of all, we're going to drag a line to this. That's going to be my hypotenuse. That is my hypotenuse. And then we'll treat this like a reference angle where we're going to go directly to the x-axis. So wherever the x-axis is closest, that's where you're going to make your triangle. So right now we're going to go right there. That's my closest path to the x-axis. And that is my triangle. And the angle right here is going to be the angle, is going to be our angle that we're actually going to do our sine, cosine, tangent, and all those from. So your angle is always created by your hypotenuse and the x-axis. So this is always your angle. This is never the angle we're talking about. It is always, this is the angle we're talking about. Once again, quickest way to the x-axis, and your x-axis creates your angle that you're looking at. Well, since this is the point 4, 2, the base of this triangle is 4 units. And the height of it's going to be -2. Now, no one freak out. I don't need to hear this. In geometry, triangles can never have a negative side. We're in Precalc now. You deal with it as being a -2. It will stay a -2, all right? So don't change it to positive, because in geometry you couldn't have negatives. Here you can. So we'll leave that as a -2. Now we just need to find that hypotenuse. Once again, all we have to do is do our 4 squared plus -2 squared equals c squared. Well, 4 squared is 16, plus 2 squared, which is 4. So that's going to be 20 equals c squared. You take the square root of both sides, and c is going to equal the square root of 20. What is the square root of 20 simplified down to, Brian? 2 square root of 5. And if you're not sure where that came from, let me just quickly. So square root of 20 is really square root of 4 times square root of 5. All right, then we have everything we need. Now we can do our sine. Our sine of theta is going to be opposite over hypotenuse. This is our angle. Opposite is going to be -2. So we'll have -2 over 2 square root of 5. Let's simplify that. So that's going to be -1 over square root of 5. Multiply the top and bottom by square root of 5. And you are going to get negative square root of 5 over 5. Our cosecant is going to be the reciprocal. Be smart. Be smart about this. If I took the reciprocal of right here, I would now have a square root in the bottom and I have to simplify it again. What if I take the reciprocal of this one? Then I just have square root of 5 over 1, which is just square root of 5. So work smart. See if there's one where you can take the reciprocal and make it work for you. So it'll just be negative square root of 5. I guess we can put over 1 if it helps you in your notes. All right, cosine. Cosine's adjacent. My adjacent is 4 over 2 square root of 5. Simplify that. That's going to be 2 over square root of 5. Multiply the top and bottom by square root of 5, and you'll get 2 square root of 5 over 5. My secant is just going to be the reciprocal. Work smart. Take the reciprocal of that one, and you will get square root of 5 over 2. All right, tangent. Tangent should be easy because there's no square roots in there. Tangent is TOA. That's opposite over adjacent. Opposite is -2. Adjacent is 4, so it's -2 over 4, which equals -1/2. Our cotangent of that angle is going to be the reciprocal of this, which will be -2 over 1, or just -2. I don't care how you leave it. I like having the fractions in my notes so I can see that I did the reciprocal. Give you a sec to make sure you have all those written down. Any questions on any of those? I go through this stuff pretty quick because the majority of you know this and get it, but there are several of you out there that won't know what's happening. Please stop me and ask questions. We just don't have a ton of time to get through a ton of material. We all okay with what happened here? Okay. Our next one, we're supposed to plot the point -3, 4. So -3, 4, 1, 2, 3, up 4, 1, 2, 3, 4. That point right there is -3, 4. Our hypotenuse always comes from the origin. And we are always going to connect this to the x-axis. So you're either going to drop or raise it. What I'm going to see on the test is people doing this. And you'll get close to the right answer, but a lot of your answers are going to be wrong. It is always connected to the x-axis. Always connected to the x-axis. Once again, do I always tell you every single note you need to write in your notes? No. So if you need to put a little note to yourself that you drop it to the x-axis, you need to write that. Your theta is always going to be the one created by the x-axis. So it's always going to be the closest to the origin. All right, that being said, if my y value is 4, the height of this triangle is 4. If my x value is -3, the base of this triangle is -3. We can either do -3 squared plus 4 squared equals c squared, or you can recognize it's a 3, 4, 5 triangle. Your hypotenuse will always be positive. Your hypotenuse will always be positive. All right, that's nice. It's always nice when you don't have square roots because you don't have to simplify stuff later on. Our sine of theta is going to be opposite over hypotenuse, which would be 4 over 5, which means the cosecant is the reciprocal of that, which will be 4 over 5. Cosine is going to be adjacent over hypotenuse, so that's negative 3 over a hypotenuse of 5. Our secant of theta is going to be negative 5 over 3. Our tangent theta is going to be a TOA, which is opposite over adjacent, so that's going to be 4 over negative 3. And so our cotangent is going to be negative 3 over 4. Brody.
Why is it wrong if you didn't connect it to the x-axis? Because I don't see the difference. See what I'm saying? For the triangle?
Yeah, so if I messed up, let's see if I can erase this. Actually, let me just put it in a different color. So let's say I messed up and put the triangle, what color will stand out? Maybe purple. Put the triangle like that, right? Yeah. That's what you're saying. Then your theta would be right here. And that top would be negative 3. And this side would be 4. Then my sine would be opposite over hypotenuse, which would be negative 3 over 5. But it should have been 4 over 5. So all your numbers will be right, but they'll be in the wrong orders of sine, cosine, tangent. Okay. And the whole reason is because this is a slightly different angle than this. Mm-hmm. Right? If this is 30 degrees, you're finding the sine of 60 degrees, which is going to have a different value. Looks like it's going to work at first, though, doesn't it? Yeah. So make sure it connects to the x-axis, always. We'll be doing a lot of that later on. All right, find the value of x round to the nearest tenth. Well, let's talk about this real quick. All right, we have sine, cosine, tangent. So I'm looking at the angle that they gave me. First of all, could we come up with that angle if we wanted to? Would it be hard to get this angle? No. It's just, what's the measure of all the angles of a triangle when you add them together? Anyone just shout it out? It's 180. So you just do 180 minus 90 minus 42 and you get that angle. You're going to need to do that in the homework on some of the problems. All right? So we have 42 degrees. So I'm thinking, okay, we have tangent, we have cotangent. I mean, not tangent. We have tangent, cosine, and sine. I'm going to look at what value they're looking for. They're looking for x, and they give you the hypotenuse. Well, x is adjacent and hypotenuse. So what you should be thinking is, well, you know what? Cosine of an angle equals adjacent over hypotenuse. Then you just fill in any information they gave you. They told you the angle is 42 degrees, so you're going to put 42 degrees in place of that. So we have cosine of 42 degrees equals, my adjacent is x, so we'll have x, over my hypotenuse is 18. Well, now to get x by itself, you're just going to multiply both sides by 18. So if you multiply both sides by 18, you're going to come up with x equals 18 times cosine of 42 degrees. Is 42 degrees on my unit circle? No, it is not. So that means you're just going to take out your calculator. So let's take out our calculators. Make sure our calculator's in degree mode. And just type in 18 times cosine of 42 degrees. You should get out, unless mine's wrong, 13.4. Is 13.4 right? For anyone that's done it? Okay. So it should come out to 13.4. If you didn't, double check to make sure yours not in radian mode and it's in degree mode. Now you're going to have in the homework, it's going to ask you for this side as well. In which case you could just use sine. In fact, let's just go ahead and do it while we're on this problem. Let's say we're going to solve for y as well. All right, to get to y, we're just going to use sine of theta equals opposite over hypotenuse. In this case, sine of 42 degrees equals the opposite, which is y, over 18 degrees. So y is just going to equal 18 times sine of 42 degrees. Can someone do that for me? I don't actually have that. I just decided to, bless you, throw that in there because you have it in the homework.
Well, under the nearest 10
It's just 12.0?
Yeah.
Do you have confirmation on that? Everything's good? Cool. So about 12.0. And why I put 0.0 is because that's where I rounded to. All right, questions on finding sides given an angle. You will have to do that in your homework. Yeah, Leo.
Why is X? Why do you put 42 degrees for cos?
I did it for both of them because it says a cosine of a given angle. That's the angle I'm looking at. This is my theta, kind of. Equals adjacent over hypotenuse. Well, my adjacent's x. You agree with that, right?
Yeah.
And my hypotenuse is 18. Well, this theta right here is actually standing in place of what the angle is. What number is actually in that angle. So inside that angle is 42 degrees. So I can replace theta with 42 degrees. In other words, whenever I put theta down, I'm actually holding a place for a degree. Okay? And if you know the degree, replace it for your theta. Does that make more sense?
Yeah.
Okay. All right, inverse trig functions. Inverse trig functions. They just undo. They undo. Remember, when I take the cosine of a number, I end up with an answer. When I take the inverse, I end up with the angle. And let me show you what I mean by that. So it says, find the measure of theta round to the nearest tenth of a degree. So that's my theta right here. This is a degree, right? Somewhere in here is a degree. I need to figure out what that degree is. Well, if I'm looking at theta, I'm looking at, well, hey, 6 is adjacent to it. 6 is adjacent to it, and we have a hypotenuse. And adjacent and hypotenuse sound like cosine, where cosine theta equals adjacent over hypotenuse. In this case, we're going to fill in the information we know. I don't know theta this time. Before I knew it was 42, now I don't know it. I do know the 6 over 9. But in order to find out what that angle equals, I need to get rid of that cosine. I need to get rid of that cosine. I need just theta on that side. The only way to do that is to take the cosine inverse of both sides. And we'll take the cosine inverse of 6 over 9. The whole reason is because inverses undo each other. Cosine inverse of cosine dissolves, and you're just left with theta on that side. So we have theta equals cosine inverse of 6 over 9. Is 6 over 9 on my unit circle on any of my values? Nope. So you're just going to plug that in your calculator. So you're going to type in cosine inverse of 6 over 9. It does say round to the nearest degree. So we are going to be in degree mode. And if you do it correctly, you should come out to, and correct me if I'm wrong, it's going to be about 48 degrees. That work? 48 degrees? Awesome. So if you need a degree out, you need to take the cosine inverse of both sides. All right, everyone quickly look at number 23 in the homework. Look at number 23, because I just want to set it up so you know what's actually happening. So 23 gives you an alpha, which is 60 degrees, and it gives you a C, which is 20. In the direction, it says you're supposed to draw a picture and then find every other missing part. So this will be the triangle you draw for this. So each of these triangles is going to be a right triangle. And it says one of the angles is 60 degrees. So we're going to call this one my 60 degrees. Note it's an alpha symbol, which means across from it is going to be side A. This is my beta, so across from that is side B. And it says my C, your C will always be your hypotenuse, is 20. What it's telling you to do is find that angle, this side, and that side. Angle's not hard because it's just going to be 30. 30, 60, 90. Then you have to use sine, cosine, or one of the two to find this one. We did that in the notes today. All right, so that's how you start those, just in case you have some questions on those. And I do have them all in the answer key laid out how I did it. All right, with the remaining 5 minutes, what questions do we have from the homework? What questions do we have from the homework? Brody. 41?
Yeah.
All right, 41 says tan inverse of 0. Tan inverse of 0. So we're looking for the tan inverse of 0. So what we need to do is we need to go to our unit circle. Let's go ahead and put another one up. And figure out where tangent equals 0. Well, tangent equals 0 right here.
Yeah, because then you put, like, see, I thought it could also be pi on 180. I mean, pi and 180. Because, like,
It could be pi on 180, except for the fact that tan inverse is only in those two quadrants. Is that cotan, right? Yep. If ever you come up with two possible answers, it means you just didn't put it in the right two quadrants that are possible. Other questions? So that should be 0 or 0 degrees. Yeah, great. 67. 67 says, find the sine inverse of cosine of 2 pi over 3. So the first thing I'm going to focus on is that cosine of 2 pi over 3. So we're going to go to our unit circle and find 2 pi over 3. 2 pi over 3 is right here. My cosine value is -1/2. So I'm going to go ahead and replace cosine 2 pi over 3 with -1/2. So we're going to have sine inverse of -1/2. Right? Because our cosine of 2 pi over 3 equals that -1/2. All right, sine inverse of -1/2 tells you to figure out where sine equals -1/2. And remember, sine inverse is only in quadrants 1 and 4. So when I'm looking for my -1/2, I need to look in quadrants 1 or 4. Well, -1/2 for sine is right here. But you can't use 11 pi over 6 because that means you went through quadrants 2 and 3, so we have to go the negative direction, which is going to be negative pi over 6. So your end answer is going to be negative pi over 6. Make sense? Good. Dan, you got a question?
I just solved it.
Awesome. Good work. That's what I like when I don't have to do anything. Other questions? All right, guys, just a reminder, test corrections are due today. There's not a ton of people signed up for today. Also, a quick reminder, if you're doing test corrections, what we've been faulting on that page, it should have your answer and an explanation on how to do it. The more points you have off, the longer that explanation should be. So if you lose 3 or 4 points, it better be kind of a step-by-step thing, because I'm going to ask you questions, and if you don't know how to do it, you're not getting the points even though you have it written down correctly. You need to know how you did it, and I need to see it laid out right there on how you did it. So that's due today. Test on Wednesday. So my advice to you, this homework isn't, well, it's okay. Maybe start reviewing concepts. The test is only 5.4 through 5.6, but you still need to know all the unit circle values. Make sure you know your entire unit circle, sine, cosine, and tangent values. It's the only way you're going to do well in this test. All right, guys, have a wonderful Friday. Have a good weekend.